My name is Constance Caramanolis. I was an Envoy maintainer up till a few weeks ago, and I'm here to talk about reducing mean time to detection of incidents with an Envoy service mesh. Yes, I do come from Lyft, and so that will be the context of how we're seeing everything today. So first, I would like everyone in the room to close their eyes and imagine you're back home in your bed. It's middle of the night. You're getting the best sleep you could ever get while away at a conference in a hotel room. And then you hear, dring, 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 dring. Pager duty is waking you up at 3:39 in the morning. Pager duty is letting you know that front Envoy at Lyft success rate has dipped below 98%. This is where the adrenaline kicks in. You're no longer asleep, and you start to panic. Who deployed at 3 o'clock in the morning? What do I do? How do I fix this? Lyft is hard down, and I have no idea what to do. And so this is how I look like at 3 o'clock in the morning when I get a page. Good thing is, it's actually the afternoon, and none of us are on call for Lyft, or any of our, hopefully none of our services at our own company. So as a group, let's all breathe in and breathe out. Today, what I'm going to do is walk us through this incident and how an engineer at Lyft would take steps to remediate the situation. And obviously, we're going to be using Envoy to achieve that. Before we actually start breaking down the problem and the page, here's just a simple reminder of what Lyft's architecture was. I wasn't joking when you say you'd see this format of our topology many, many times. We have an edge Envoy that proxies all the requests that are coming from various clients on the internet. And then it forwards requests to internal services. On each of our services and edge Envoy, there's an Envoy running that handles ingress and egress traffic. So at Lyft, whenever we have a page, we have to send an incident response report email. The first one goes out. Edge Envoy is paging due to success rate dip, investigations ongoing in operations, limited understanding of impact, update, whenever we figure something else out. So this is what we know so far. We know that calls coming into Edge Envoy are failing. This is a P0 page at Lyft. This is where everyone wakes up and they snap to attention. This also usually means that there's some form of customer impact. And so we're on the West Coast. 3:49 is almost 7 a.m. on the East Coast. New York's a big market. Boston's a big market. East Coast is something to take very seriously. So just because we are sleeping doesn't mean that other people across the country are. So we need to figure out what is causing the success rate dip. On the left is a little bit of diagram of showing what edge configuration look like. We do usually group routes by domains and then the routes, and they'll determine which service it needs to go to. For this one, we're going to be caring about the prefix show map, and that forwards requests to map render. And everything else under this domain, if it hasn't matched a previous route, will go to the render service. The page that triggered the alarm and our unfortunate wake-up call is just a ratio. It's looking at the total amount of 5XX errors over the total amount of requests sent. And so one of the easiest way to actually identify what service is causing it is just look at the 5XX per service from the point of view of Edge Envoy. And as we can see here, it is a map render service. For whatever reason, it is returning an abnormal amount of 5XX. So to keep on figuring out to see what we know so far is we know that a request from some clients to map rendering are returning an error. And with a little bit of side investigation, we actually know that clients can't actually render a map. And if you can't render a map, no one's going to request a lift. So this is pretty bad. So how do we keep on figuring out what's going on next? This is a snapshot of what our service dashboard is at Lyft. And this shows pretty much all permutations between one service and everything else it talks to. You can also limit it between service A and service B. This will show you the amount of requests, upstream response time, success rate. What's really interesting about this is it applies to every single service at Lyft since Envoy is used at every hop. And the one thing that we want to look at, since we know that map render is the one returning errors, is it the map render service itself, or is it forwarding errors that it's seen from other callers? So we're going to look at the service errors from upstream services. And we're going to see here that it is a driver service. So instead of looking into how we can make map and focusing our attention on map render, we're going to keep on following the errors until we see some root cause. If it's either a service itself or an external service, or maybe something else along the line. Now, one thing I want to clarify, upstream versus downstream. We, at Envoy, we use those terminology as long as we view it in the context of the response. Map render is downstream to driver because it receives the response. Driver is upstream to map render because it sends a response. One really awesome thing about Envoy that I will not show you today, because it could actually take about 2-3 hours to go through the entire, seeing all the different statistics, is that you're able to see all the stats of from map render sending upstream requests to driver. And from the driver point of view, you get to see all the calls going into it. And so now we have a little bit clearer picture of what's causing the page. Right? Now we know that driver is returning errors, but why is driver returning errors? A really nice thing about this is that's reiterating the point that we have Envoy running everywhere, is that let's apply the same methodology that we use for map render. Let's look if any of the upstream services are causing errors. And once again, in this case, it's actually an external service called photo filters. And as we're figuring this out, not too long ago, there was a new feature called photo filters that drivers would actually be able to apply, kind of like the snapshot filters to their little photos. Very popular service in this hypothetical situation. And unfortunately, is that when this is returning errors, no maps are being rendered. So something is going on, something wrong is going on. One other thing we note too is actually the CPU percentage of the driver instances is really high. That's not so good. Now this is the root cause. We stepped from the initial page where we had a success rate ratio, and then we just followed the errors from the initial hop on edge all the way down to photo filters. Root causing is only part of it. The actual interesting part is remediation, but we'll get to that in a minute. Once again, we need to send an update email to everyone. So the incident report email says that we know what's causing the issue, but we're still talking about how we want to remediate. We also know that now the maps aren't being rendered in clients. So first thing we're going to do, if we know our external provider is serving us errors, let's contact support. Downside is that there is no ETA for the fix. They know that there's an issue, but they can't figure it out. Their machines are hosed. They're not be able to take more requests. We are pretty much stumped. Once again, panic and chaos. No one can control the whole internet, and so since we can't fix our errors, you could be a little bit stumped there. Let's talk about remediation. So first thing we can do, so we have two options. Well, one of two options. One, we can wake up a developer, and ask them to start coding better error handling at 4 o'clock in the morning. Unfortunately, we all know that this is not the best way to handle issues in the middle of the night. So the second thing we can do is potentially reduce the load on the photo filter API. We were talking to support, since we know that their instances are, all of them, their machines are pretty saturated right now, reducing the load might actually help them get back to a stable spot and return fewer errors. Now this is where Envoy is really, really fascinating, is that we have this thing called maintenance mode. And what maintenance mode will do is that within your configuration, you specify all the clusters, upstream clusters that you talk to. You can eventually say, hey, in this example, the external photo filters upstream service is not doing so well. I would like to shed 5 or 10% traffic away from it. And what that will do is it will actually automatically return a 503 to the caller and not even forward requests to the service, the upstream service. So this could give a chance for photo filter API to recover, and then after give the driver service an opportunity to go through its error handling path. And so this is an example of, throughout the root cause path, of where we're applying one key through Envoy maintenance mode. So now we applied the maintenance mode and we're waiting. We give it a few minutes. We apply maintenance mode through a runtime key, and that'll usually take about a minute or two to get everywhere. And so after waiting a few minutes, you see, are things better? Well, unfortunately not. Success rate is still, the amount of errors that driver is returning is pretty high. And the actual CPU percentage hasn't changed. So we have two options. Clearly, our driver service can't handle this amount of requests, so we can scale up. One unfortunate thing of our current infrastructure at Lyft, we're migrating to Kubernetes, it's not done yet, but scaling up for us is very slow. It can take about 20 minutes for a new instance to come up. And 20 minutes in our industry is kind of detrimental, right? It's easy to lose trust, really hard to regain that trust. So whenever a rider can't request a ride for a few minutes, they're going to switch to an alternative. So scaling up is an option we can add to this, but it's still actually not going to do anything to help us get riders back in the car. One thing we actually were realizing is that since this new code path to applying the photo filters is that the circuit breaker settings weren't properly configured. And what the circuit breaker settings do is tell all downstreams that are communicating to driver or any other service is I know how many max requests, in this case is H2, this can actually handle. And if you misconfigure it, you can be flooding your entire service. So one thing we do here is that we're going to adjust the circuit breaker settings to driver service to give it a better chance to reduce CPU saturation. And that way we'll still be returning some errors, but that might actually give us a better chance at keeping those whose requests are going through be successful. And so just showing you here, on top of the maintenance mode to the photo filters, we are applying circuit breaker settings. And now we wait. We give it a few minutes. We're testing it manually. Can we still request rides? Unfortunately not. And this is where, at this point, it's middle of the night, and we've been trying to think about different ways to work around the driver code, map render code, different photo filters, and it's just not working. And so when we're releasing this feature, we released it under a runtime key in Edge Envoy. And what this runtime key does, it actually says, once the runtime key is set at 100%, when something matches to it, send all traffic there. This is really useful when you're rolling out a new feature. If you're testing something out and you want to send only 5 or 10%, set this runtime key to 5 or 10%, and only 5 or 10% of requests will go there, and everything else will default to the previous matching route. And so what we do is we decide to shut it down. This code path, as well-intentioned as it was, had some bugs in terms of handling error cases. Things weren't fully fleshed out, and this is not something that we need to solve at 4 o'clock in the morning. We're going to detour all traffic from show map that shows to map render and go back to the legacy path. Now that we know that we've decided to switch all traffic to the legacy path, we're going to wait. We expect everything to go back to normal, and we're going to wait. While we're waiting for everything to go back to normal, let's do a recap. So first, we started off with identifying that the photo filters, an external service that us at Lyft, or if for your own company, someone that you have no control over, and they are returning a set of errors, you can stop sending requests to them without having to make any code changes. This is called maintenance mode. After realizing that this doesn't work, we can take another step back and notice that we have poorly misconfigured driver and that we're sending too many requests that can't be handled by the service. So let's reduce the amount of requests that we send to it and hope that things get better. Unfortunately, they do not. And as a last result, or as a last option in this case, we're just going to stop sending all requests down this path, and we're going to find a better solution in the daytime when we're all well rested. And we're going to go back to the legacy path that had been working for X amount of months, days, years. After this amount of time, we actually confirmed that the map is correctly rendering and on all clients, application success rate is back at 100%, and that we can start serving rides again. Now this is a contrived example, but it is meant to show just a few of the ways that Envoy can be used to handle and remediate an incident. I talked about circuit breaker settings very quickly, but we can also handle max pending request, max connections, so it doesn't only apply to H2. Outlier detection, if it were the case of the driver service, instead of it being the entire fleet that was being hosed, you could actually imagine that maybe 2 or 3 of however many instances you have are just poorly performing. Outlier detection will look at all of the 5xx per instance and identifies the ones that are poorly behaving and stop sending requests to them for a certain amount of time. and see after a certain amount of period, is it healthy again? Can it respond to requests properly? If it can, it'll bring it back into the pool and keep on sending requests to it. But if it starts failing again, kick it back out. Access logging. One thing that we could do once we identified that the map render service was an issue is you could actually look at the access log of which prefix was being hit. You can group those and find it out of the pattern. Tracing. If you were earlier at Lita's talk, Lita talked just about how tracing shows the entire flow of a request. Sometimes it's not in this. Sometimes it is in a page in the middle of the night, but there's a weird one-off instance of something being wrong. You can use tracing to identify, in particular cases, what is going wrong there and see everything in a deep dive. Another example with the Edge Envoy configuration. What if someone misconfigured an Edge and you start returning 404s? If you're using a static config, it could take you a while to actually remediate that. If you use the dynamic configurations, RDS, CDS, call them XDS, all of the discovery service APIs, you could actually roll out a bad configuration, give it 30 seconds, a minute, realize it's bad, and then send another update to remove that bad configuration in a matter of minutes. HTTP header options. If it's a bad request timeout, retries, these are things that actually we configured within the header and not something that's actually in the code. Traffic shifting is what I showed you in terms of the runtime switch. And maintenance mode was the first thing that we talked about, photo filters. So how has this helped Lyft? You don't have to be on the networking team or on the driver team to actually apply this knowledge. This knowledge applies to everywhere that Envoy is used. So the benefit of this is once you teach your engineers these set of tools, they can apply it anywhere. I have two beliefs when an incident happens that the first thing you need to do is keep the lights on. Most of us work in a world where if you're off for even 10 seconds, 30 seconds, our customers get really angry. So keeping the lights on is a big priority. And the second priority is then allowing those who have maybe a deeper understanding of the application logic or anything that's required to, or like anything associated with the root cause, they can focus on fixing that while other people are keeping the lights on. Why this is even cool is that you can actually have a junior engineer who just joined the driver team. They can be applying the maintenance mode, they can be traffic shifting, turning on and off a route, while a senior engineer is debugging with the photo filters contact support. You can scale yourself and not have it be stuck to only one set of team. And with that, it was pretty short, but leaves a lot of time for questions. So I want to say thank you, everyone, and questions, please. Yeah.
Is there a concept in Envoy of like actually configuring a backup and having it be able to toggle itself over?
Like automatic remediation. So his question was, in our configuration, we had a backup. And is there a concept in Envoy that you can do automatic remediation between one and the other? We don't have that, but it is something you can actually program around. And you can either do like consuming the metrics around like certain endpoint being wrong, and then after do a little bit of a loop in terms of updating the configuration, but there is no automatic way right now. It's something that would be really cool.
How did you get that screenshot of the phone call? Was that really at 3 a.m.?
Oh, I turned off, that one wasn't really at 3 a.m. It's because I always forgot to take snapshots at 3 a.m., but I did actually just tweak the phone, time on my phone. But I have definitely been woken up at all times of the day.
You mentioned using the XDS APIs to configure Envoy in an incident. Does Envoy have an audit log so you can keep track of those events?
Sorry, say that again.
Is there an audit log in Envoy when you change the quantity via the XDS API?
I'm sorry, I actually can't hear you.
Is there an audit log in when you change config?
Auto log?
Audit.
Aud log? That's probably based on just how you actually implement it yourself. Right, like so that's where we would have our logs with, like for our configurations, we actually put everything committed within a Git repo, and we use that SHA as our version history. And so then we can see what we deployed and what we haven't deployed, and that's how we keep track of all that. Questions? Anyone? Anyone from that side? No? Great. Thank you.